In nature, balance is everything. Just like yin and yang, opposite forces shape the world around us. Hence, we present to you the yin-yang forces of particles. Among humans, balance often arises from differences. Opposite energies attract, forming bonds that are both meaningful and strong. It grows deeper the closer they become. At the microscopic level, a similar balance exists. However, not between human cells, but between electric charges in particles. Just like humans, particles are influenced by opposite charges, positive and negative. Some molecules share their electrons equally. There are balanced charges within molecule. We called them non-polar molecule. Others share electron unequally, creating regions of partial positive and partial negative charge. These are called as polar molecules. This unequal sharing of electrons occurs due to a property known as electronegativity. Electronegativity is the tendency of an atom to attract shared electrons in a chemical bond. Some atoms have a stronger ability to attract electrons towards themselves, just like the oxygen here. When electrons are pulled closer to one atom, this will create partial charges within the molecule. As you can see, oxygen has more area covered in red color, indicating more electrons are attracted. As a result, polar molecules develop a dipole. Dipole is when polar molecules have two distinct ends, one partially positive and one partially negative. Let's look at these HCl molecules. Since they are polar molecules, when they come close to each other, dipole-dipole force is formed. When polar molecules come close together, the positive end of one molecule is attracted to the negative end of another. This electrostatic attraction between permanent dipoles is known as dipole-dipole force. Dipole-dipole forces form naturally as molecules rotate and align themselves to maximize attraction. Dipole-dipole forces are intermolecular forces, meaning they act between molecules rather than within molecules. Dipole-dipole forces only occur in polar molecules. Its strength is also depending on the molecule's alignment. When the alignment is favorable, the attraction becomes stronger. This allows molecules to remain closely associated. Next, let's look into the factors affecting the strength of this force. Firstly, the difference in electronegativity, or often called as polarity. Greater polarity of molecules will result in stronger attraction between molecules. Secondly, distances between molecules. The closer they are, the stronger the attraction. So basically, the larger the dipole moment is, the stronger the dipole-dipole forces between molecules. Now, let's compare this force with other forces. Firstly, we have London dispersion forces. Secondly, dipole-dipole forces. Lastly, hydrogen bonds. Now, let's take a look closer and closer. Apparently, hydrogen bond is the strongest. Dipole-dipole forces come in second, while London dispersion is the weakest forces. Lastly, let's dive into its examples and applications in daily life. A common example of dipole-dipole forces can be seen in hydrogen chloride molecules. The difference in electronegativity between hydrogen and chlorine creates a permanent dipole, allowing neighboring molecules to attract one another via dipole-dipole forces. Another example is flowing water. Water can flow smoothly because the H2O molecules are attracted towards each other. This is due to the condition which oxygen is partially negative and hydrogen is partially positive. Fun fact, the stronger the dipole-dipole forces between molecules, the higher the boiling point of a substance. In conclusion, molecules demonstrate balance through attraction that occurs due to difference in charges, just like yin and yang. Indeed, balance is achieved through interaction between opposite energy. And that's the end.